Hello, everyone. On behalf of Ideas, I, Anisha, want to welcome you to our webinar on where AI meets food packaging and freight logistics. We are extremely honored to have with us Mr. Vish Puttagunta, who is the Chief Technology Officer and the Principal Data Scientist at DIVERGENCE.ai. I'll talk more about him, but briefly before that, I would like to go over ideas for those of you who are not aware of our organization and what we do. Welcome, Vish, to the webinar. And I'm just going to briefly take some time, introduce ideas, and then I'll hand over to you.
Good to be here.
So IDEAS is the International Data Engineering and Science Association. And it's a non-profit organization, and our mission is to bridge the gap between academia and industry in the fields of data science, machine learning, and artificial intelligence and blockchain technology. We started in 2016, and we have come a long way organizing a lot of conferences all across the US in Dallas, Chicago, and Los Angeles, and different kinds of hackathons. And here are some glimpses from the Los Angeles Convention Center where we had our 2018 SoCal conference. This is from the Chicago blockchain and New York. That's Pasadena, and then USC. So we have pretty much organized and covered a lot of universities on the East and West Coast, and we aim to keep up with the mission and bringing all the data enthusiasts together and add to the pool of knowledge. Some more glimpses. And if you want to know more about us, please visit our website and feel free to email us and connect with us on various social platforms. There's the QR code to get to all of that. And now I would like to welcome Mr. Vish Puttagunta, who is the Chief Technology Officer and Principal Data Scientist at Divergence.ai. He helps companies incubate data-driven teams centered around logistics, marketing, food packaging, fraud detection, and food safety. Additionally, as a co-organizer for DFW Data Science Meetup, Vish also enjoys organizing talks centered around data science and mentors students and professionals transitioning into the field of data science. Thank you, Vish, for joining us this evening. And please, we are very eager to hear you talk about AI in food packaging and logistics.
Glad to be here. Can you hear me okay?
Yes, we can.
Can you see my screen?
Yeah.
Okay, great. So let's get started. So, you know, when I think about AI, I always think about what is it that we can do to improve the health. And I always think about what can be done with AI and machine learning and statistics, what have you, that we could not really do even 2 to 3 years ago, right? So that's what excites me about AI, right? So yes, there's robotic process automation. Yes, there's going to be a lot of jobs that are going to be lost, but at least the kind of problems that I try to tackle at Divergence.ai are the ones that things could not be done, right? You know, because it was just too much. This kind of compute capacity wasn't available. These kind of opportunities were not available in the past. So in this video, you know, the big question that I'd like to ask is, you know, how can we get the fresh food, you know, fresh and tasty food at our table? So I'm going to discuss about, like, you know, the center of this talk is going to be a food packaging plant. So I want you to think about any packaging plant that is going to buy a lot of raw ingredients, package it up, and then ship it out, right? And I'm imagining that we're going to be doing a lot of fresh food without any additives and without any preservatives. So from the time that a tomato or some kind of a fresh produce is plucked, you know, it's a ticking time bomb. It has a very limited shelf life, so it has to get into the hands of the consumer as soon as possible. So from the time that it gets out of the farm to the time that it comes to the packaging plant, to the time that it's distributed out, what are the different artificial intelligence and statistics techniques that can be applied to make sure that the products go through the system as fast as possible and as efficiently as possible. So I'm going to cover a couple of key concepts, and through each of them, we're going to talk about the different kind of problems that can be solved with these techniques. And I will not talk too much about deep learning, and I want to make sure that I highlight that a lot of the problems that we face in real life don't necessarily have to deal with deep learning. So stepping in, if you just think about the key concepts, as a data scientist, one of the first things that was very, eye-opening for me is the importance of what ERP is, enterprise resource planning. And this is really how a company really operates. So, because as a data scientist, sometimes you're given a problem, but the thing is you miss the context of what the implication of what you're doing is. So in order to understand that, it's really important for you to understand how a company operates. And ERP is at the core of how any company operates. So we're going to cover what ERP is at least at a very high level. We're going to talk about time series forecasting, which comes quite a bit in manufacturing, packaging, these kind of areas. Then we're going to talk about this specific area called combinatorial optimization. And then we're going to talk about process mining. And then, yes, we will mention AI and deep learning. But I always want to make sure that it is just not about AI and deep learning. There's a lot of concepts that come together to solve a realistic problem. So let's first understand the backdrop, which is the ERP. ERP is a very vast area, but think of it as different modules. For example, CRM, the customer relationship management, is one aspect. And I always want to keep a backdrop of how does this apply to a packaging company. So assume that you're operating a packaging company, and this is the context for all this presentation. For most practical purposes, imagine that you're working or you own a food packaging plant that is buying a lot of fresh produce, grains, noodles, vegetables, meats, whatnot, and it has to deliver a lot, it has to package up these, portion these ingredients, package them up, and then ship them out. So this is the backdrop of the entire talk. So let's think about where does customer relationship management come into play as an ERP module. When we think about customer relationship management, you're thinking about marketing, meaning that how does the company get clients, right? Like, for example, a packaging client might want to supply to Whole Foods or something like that. But how does Whole Foods know that we as a company, as a packaging company, exist? So usually the marketing functions, now the sales order processing. For example, my packaging company supplies to Whole Foods. Then I need to have a system where Whole Foods can order. I can take the orders, convert them into production jobs, and supply the supply the packages to Whole Foods. Field service is another area that usually comes under CRM. We're not going to touch that over here. But in this particular talk, we're going to talk about a lot of sales order processing, like how are we receiving these orders? Are we receiving them over email? Are we receiving them over fax? Or what are the different mechanisms by which our customers are going to order from us? And then there's a whole block around operations, and the operations people are mostly worried about making sure that we are able to ship the order in time, and we are able to get the cash, get us paid in time. So when we supply to Whole Foods, we want to make sure that Whole Foods pays in time, and there could be many other groceries, many other retail stores that we are supplying to, and we want to make sure that we can be supplied to them as fast as possible from the time they order, and then we get paid. So from the time they order to the time that we receive cash is called the order to cash process. And then also purchase to pay. This is really about how we as a company buy a lot of raw materials and fresh produce from our suppliers. So we are purchasing. So we are making a purchase order to our suppliers, and then we're going to have to pay them. So what is the cycle time? So again, in the entire talk, I'm going to act as if we own a packaging company that is buying a lot of these fresh produce, packaging them, and then supplying them to a Whole Foods or Walmart or any one of these suppliers, any one of these customers. We've got to track inventory. We've got to make sure that, we got to know at any given point of time how many pounds of tomatoes do we have, how many pounds of meat do we have, and so on and so forth. And then we'll have a whole system of finance. Like, we have our own suppliers that supply to us, and we have our customers that buy from us, and all the financial transactions are logged in the financial systems. So typically, this is where, like, customers, for example, they let us know what prices they're going to buy. And then the suppliers, like, we have vendors of our own, they have suppliers of our own, and they tell us how much they're going to sell the tomatoes and the meats for, right? So I know ERP is a very vast system. Like, you hear about things like Dynamics 365, SAP, Oracle, they all have end-to-end ERP systems. NetSuite is another one. It's a very vast area, but I want you to understand that there are these 3 different modules called CRM, operations, and finance. HR management comes under operations and finance somewhere in there. But this is really how a company operates. And as a data scientist, it's really very important for you to understand, for us to understand how a company operates, and how, when we solve a specific machine learning or AI problem, where does this plug in? Does this plug in into the ERP, into the CRM system, into the sales order processing system? Does this solution plug into the operations or a production system or a financial system? So we need to be very aware of what problem are we solving, which context does this problem come under, so that we can integrate with the corresponding system very well. So the first, obviously, let's just think about, we as a company, obviously, we have to forecast what our demand is going to be. So say, for example, we have 10 to, maybe 5 or 10 customers. Maybe we're supplying to people like KFC, we're supplying to people like Whole Foods, Walmart, whatnot. So there are like a whole bunch of suppliers that we've been supplying. And the first thing that comes into mind is like, how many SKUs are we going to need to build? Like, a SKU is like the minimum unit that we're going to ship out. So how many of these are we going to have to ship out, right? So, and we want, because this is fresh produce, you want to make sure that you're not doing like a yearly forecasting or anything like that, like you would do for apparel. Usually perishable food, you're usually planning 1 or 2 weeks ahead, because the cycle times are very, very fast. So you want to make sure that you're able to predict what kind of demand you're going to have. So, and then based on that, you're going to have to decide how much of labor do we need. Say, for example, we need to produce 50,000 packages of, of SKU 1 and another 100,000 packages of SKU 2, and so on and so forth. So in order to produce that many, then we backtrack and say, okay, how much labor do we need? Do we need any machinery that we don't have available? Maybe we need to rent some machinery or something like that. But in general, like a lot of labor demand is very important, because we need to make sure that we have sufficient number of human resources available to be able to meet the production demand. And then knowing that we will need to supply 50,000 SKUs of type 1 and 150,000 SKUs of type 2, we need to now understand, can we supply this particular demand, right? What are all the suppliers that we have? If you have about 10 customers, typically there are a lot of suppliers that are supplying tomatoes and broccoli and so on and so forth from different vendors, right? So you obviously want to know, hey, will I be able to meet this demand if I go with this supplier? So there's a lot of decisions you got to make in terms of time, quantity, as well as price. So as you all know, like, time series forecasting is a regression problem, and you have a whole bunch of inputs, and you're trying to quantify how many SKUs you want to need, or what is the price going to be. So it's going to be a floating point number. There's a lot of things that you got to consider: past demand history, market conditions, seasonality. These are all the features that you're using to predict demand or supply forecasting or demand forecasting. And this is very important. As time goes along, what has really changed in the last year or two compared to what used to happen before is being able to react, right? Even in the past, you used to have the static systems that used to do time series forecasting and stuff, but with the cloud and API-driven development, you want to make sure your system is able to react. Like, say, for example, suddenly there's a winter storm. Suddenly there's an unexpected event that actually happened that could impact either your supply or your demand. you want to make sure that you take that into account in your forecasting system. And any special events, like say, for example, there's Super Bowl, and if I'm supplying to Pizza Hut or somebody like that, I want to make sure that, I'm considering these special events into consideration for my feature set. And regarding the solution space, in my experience, you tend to use statistical and signal processing techniques to do time series. And this is because you want to make sure you're able to interpret your results to the production manager or the financial staff of the company. Because, a lot of times I see a lot of data scientists getting distracted with deep learning straight away. And for every problem, they want to use a deep learning algorithm. I'm pretty sure there's an LSTM algorithm out there. But what I would caution is statistical techniques and signal processing techniques. They're very interpretable. Once you understand them, you can explain to the business users, this is why I think the demand is going to be very high, or this is why I think the demand is going to be very low. And these are you can even pinpoint to exactly which factors are causing that particular demand to go up and down, that prediction to go up and down. So I would strongly caution you, don't start with LSTMs and deep learning for time series forecasting. Stick to traditional statistical and signal processing algorithms so that you're able to interpret them to the business. And more important than anything else, you want to make sure that it is seamless. It's not just about taking a problem and doing it in your Jupyter notebook. You want to make sure that you build a system where, you get the real-time inputs. Like, for example, all of a sudden there is a winter storm, you get an input into your system, and your forecasting algorithm is able to react to that. So I would say make everything an API-based system. Once you productize the model, you want to make sure that it is able to, you convert that into an API or some kind of a reactive system so that you don't have to run another back job or something like that. So, okay, so now let's just say that, we predicted, for next week that we're going to have to produce about 50,000 SKU 1s, 150,000 of SKU type 2, and so on and so forth. Now, and I for this I need about 50 people in staff, and I have about 10 machines, and this is what I predicted this week for next week, right? So next week comes along, and at this point of time, I want to make sure that all my machinery, right? I'm scheduling the 50 people, each of them for the right machine. And you want to make sure that this is called job shop scheduling, right? So you have, like, say, for example, you have 3 machines in your production facility, right? And there's a dependency, maybe the produce has to go through machine 0 and then go to machine 1 and then go to machine 2, or vice versa. So, and before you cut, you cannot package, for example. So these are all the dependencies that have to be taken into account, right? And you also need to take into account where person A has to be, which machine person A, and the first 10 people have to be, which machine the second 10 people have to be, and so on and so forth. So these are all the constraints. And then based on all these constraints, you have to come up with an arrangement, really, right? So this is not really a machine learning problem or a statistics problem. This is a whole field called combinatorial optimization. And the key thing that you got to remember is that you're giving constraints. You're basically saying, and these constraints could be coming from business, or they could be coming from the forecasting. So, and I want to make sure you understand how these different fields of AI, machine learning, statistics, combinatorial optimization come together to solve a real problem. So for example, in the previous slide, I talked about time series forecasting, because the time series forecasting is the one that predicts what we, predicts last week, how much we're going to need this week. But once all of that is taken into account, what the combinatorial techniques, like the job shop scheduling, like the routing, what these do is they take the cost function into consideration, they take the constraints into consideration, and they come up with the schedule. They come up with the route, or they come up with an arrangement, right? So that is a job of the combinatorial optimization techniques, right? And there are a lot of techniques like, simulated annealing, genetic algorithms, a complete different sequence of algorithms that they're not like the linear regressions and the the decision trees and the deep learning. These are not the techniques that are used. So definitely I would encourage you to go look at Google or, Google has released open source their internal operations research algorithms. So definitely check that out. I definitely learned a lot from that. And these kind of algorithms are also the kind of algorithms that are used for routing. Like say, for example, you have a lot of shipments, and say, for example, I'm, Cisco Foods or one of these foods, trucking companies, and I have to go and get the produce from these packaging company, and they need to go supply to various restaurants, and the restaurants are scattered all over the city, right? So they need to decide in which order they are going to go pick up the produce and in which order they're going to deliver. Again, that's all about how do they define the constraints, how do they define the cost function, right? The cost function, you are either trying to optimize the labor cost, you're trying to optimize the fuel cost, you're trying to optimize the time per shipment. These are all the cost functions that you have to consider, that these combinatorial techniques have to be considered. So you have constraints, you have cost functions, and then it runs a bunch of algorithms, and it comes up with a schedule, it comes up with the route, it comes up with the arrangement. So this is how traditional statistics and machine learning algorithms interact with the combinatorial techniques. So let's just think about if I predicted that I would need 150,000 packages. If that forecast is wrong, right? Say for example, this forecast is wrong, then the inputs for the system is going to be wrong, and because of the inputs, the outputs are going to be all messed up. Or let's just say that last week I said that okay, I need machine 0, machine 1, and machine 2, and you come up with a whole schedule for, let's just say that these are the 3 jobs and these are the 3 machines, and I came up with this particular arrangement or this particular schedule. But what happens if machine 1 goes down, right? Then you have to figure out what is the next best schedule that we can come up with. So again, it's very important to make sure that you have a fairly good comprehension of what are the inputs, have any of the inputs changed, and the combinatorial techniques, you want to make sure that you're able to update the constraints. Like say, for example, machine 1 broke down, or these 10 people of the 50 people that we hired got sick. What is the next best thing to do given the situation? That's under the realm of the combinatorial techniques. And then we have process mining. And this is a whole different field where you have event data. And let's just think about this, right? Like if you think about any process, the process really is a bunch of events, a bunch of time series events, right? And once you, let's consider the case of an order to cash process. An order to cash process is basically where my customer orders something from our company, and then we need to fulfill the order, we need to ship the order, and we need to get paid for the order, right? And every event, like when they make an order, that order ID, that's unique, right? That's what you're tracking from point A to point B to point C to point D, all the way up until the point that we get paid, right? So we have 3 really important attributes that we track for any event. One is called the case ID. Like for example, an order ID can be considered as a case ID because that is the one thing that you're tracking across the entire process. And the second important thing is the activity ID. Like for example, them at the moment that they send us an email, an activity happened. The moment that maybe my order person responsible for taking the orders, he entered that into the ERP system and opened the production job. That's another event. From the time that I actually shipped that order, that's another event. So these are all the events that we're tracking. And the third, obviously, is the timestamp. So once you have these 3 attributes, then there are these process mining techniques. It's a new field. It came about, I mean, it was there from earlier, but there were a lot of breakthroughs that happened about 2005 to 2006, and a lot of these techniques became productized in 2013, 2014. So it's a relatively new field. And what this process mining does is it takes all these time event data and reverse engineers what the underlying processes are. And the advantage of doing something like that is that you're able to find out where the bottlenecks are. So once it figures out, hey, this is the underlying process, then it's able to identify, like, for example, in this particular scenario, it's an order to cash process that it reverse engineered. And it's able to figure out that, if one of my customers goes through a credit check, then you're going to lose 4 days because of that. So that it identifies where the bottlenecks in the overall system are. And then it identifies where the negative deviants are. Like, say, for example, we have a process set in place and somebody in our organization is not following the right process and it's causing a negative impact, then that's called a negative deviant. But maybe somebody is skipping some rules and it's actually causing a positive influence. That's called a positive deviant. And, and it's also important to understand that how process mining interacts with other machine learning techniques. Like, once you reverse engineer the process, then you can apply statistical or machine learning techniques on it. Like, for example, you can say that if the order ID goes through create sales, and instead of going through create delivery, it goes to denying credit check, you can actually predict that there's going to be a delay of you getting paid, by another 5 days from normal, right? So you can actually start to predict these things many, many days earlier, right? So this is how process mining interacts with machine learning. So, a lot of problems that could be solved with process mining are, like, order to cash is one of the really good problem that can be solved with process mining. Purchase to pay is another problem that can be effectively solved using process mining. And anything, when you think about, even when we do robotic process automation, like, say, for example, you're automating the process of inputting your invoices into your accounting system. That is a process, right? Because you first have to classify whether this is an invoice or a receipt or a settlement or something like that. And then you have to extract the information from this particular document. So that itself becomes a process. So it's not just about AI and, doing convolution neural networks and extracting the data. You have to consider that you have a process in place that you're tracking. So anywhere there's a process, you want to have a very good understanding of the process. And that's where we tend to use a lot of process mining techniques. And again, I want to make sure that no individual technique exists alone. These things play with each other, and you want to make sure that you understand, at least at a high level, hey, is this a process mining problem? Is this an AI problem? Is it a time series problem? And how do these interact with each other? And then, of course, we have deep learning. And some of the areas that we use deep learning for very heavily in this manufacturing logistics is document processing. For example, this is an invoice. In a document, you probably want to understand, where are the different fields in this document. For example, this is where the customer address is. This is how much the invoice was for. And this is the address to which we actually shipped. Or this is the address of our supplier, and this is the invoice that they sent to us, right? So making sure that you're able to identify where the metadata is in a document. And this is where we use a lot of convolution neural networks, kind of object detection technologies that to identify these metadata. The other area we use a lot of computer vision is inspecting. Sometimes you want to inspect whether the fresh produce is really fresh, and if it has a lot of quality checks, and that's something that you could definitely verify nowadays very well with very well-known convolution neural networks. And then you have text analytics, right? Like, this is a problem that we solve where we tap into the email and we are trying to classify whether it's an order or if it's a prospective new customer that's requesting a quote. Like, so RFQ is request for quote. So if they say, hey, I need this product, I need 50,000 of them, can you supply them? At what rate are you going to supply them? So this could come from a prospective client. So we want to first classify based on the email, is this an order that is for an established client, or is this a new, potentially a new client? So you want to classify the information, and then you want to then extract the information. Like, say, for example, your customer ordered 20,000 units of a particular type of package. You want to make sure you extract this information from the email. And you want to understand, is this a new customer? Is it a new opportunity? Or is it an old customer that's needing new things? So this is where text analytics comes into play. Again, when we're dealing with deep learning, we want to make sure that at least we learned our lesson. Initially, I was very heavily into deep learning, so I tried to automate 100%, any particular task 100%, and that was very difficult to get that level of accuracy. And because of that, what we do now is we understand this whole thing as a process, right? So for example, these invoices that are coming from various suppliers that could all be in different formats. And that's what makes the automation very difficult, because these machine learning algorithms and deep learning algorithms need lots of examples, right? So what we do is we have a process that is set up, and we use a lot of human in the loop. So we make sure that initially there are a lot of humans that are annotating this data. And as they annotate more and more data, we train the algorithms. And there are going to be times when there are going to be new invoices that we haven't seen before. And we want to make sure that we have proper processes in place to route those to humans instead of machines, right? So you always want to make sure that you understand the underlying process, regardless of what kind of problem you're solving. And annotation quality matters a lot, because these machine learning algorithms that need a lot of data, especially annotated data. Like for example, if you have like 100 different kinds of invoices that are coming in, you want to make sure in each kind of invoice, where is the address of the supplier? You want to know where is the total amount that is due, where is the date, and so on and so forth. So you want to make sure that you have set up solid pipelines, like workflows, in place. So it's just not a pure deep learning play. You want to make sure that it's completely integrated into the ERP system. You have backend annotators that are able to annotate the data. You want to have quality checks to make sure that they're not making too many mistakes, because mistakes are going to be made. So again, in deep learning, one of the things that you want to understand is like anything, when you're trying to automate any task, you want to make sure you're able to prioritize the task. And a lot of times what we've learned is that you don't want to automate tasks before knowing if that is a task that is worth automating, right? So you first want to understand, like, where in the whole process, which task is causing the most amount of, one second, I guess I'm getting a chat. Anyhow, I'll save the questions for later, but, to wrap it up, you want to make sure that you're able to prioritize the task, which means that you need to understand the impact of each particular task, the cost associated with each particular task. So again, you want to make sure that whatever you do in AI or machine learning or statistics, it integrates back into the business, into your ERP system, whether it is CRM system, whether it is operations, whether it is finance. For example, a lot of invoicing comes under finance. So you want to make sure that all of this data seamlessly goes into financial systems. So to summarize, here we covered quite a number of tasks over here. We covered ERP system, we covered time series forecasting systems, we covered combinatorial optimization systems, process mining systems, and deep learning systems. And to summarize, let me just, so to summarize, you want to understand the business processes, and you understand what ERP is. And I gave you a couple of references later on in this presentation. I personally found Dynamics 365 ERP to be a pretty good ERP system to get started on, because it's a cloud. They all moved the ERP system on the cloud. And you always want to understand the business impact, because a lot of times, if you do not take care of this, you are probably solving the wrong problem. You always want to be doing the minimal amount of effort and the maximum business impact. And deep learning is awesome, right? But a lot of times, we found it to be a distraction. And I emphasize this because there's such a big buzz about deep learning that people get so distracted by it, right? And it's great at solving some problems like object detection, NLP, text analytics problems. It's great at solving certain problems, but do not make the mistake of thinking that that can solve every problem, right? Understand various fields at the high level, because when you're going in, you want to, at least at a high level, try to classify, hey, is this a statistics problem? Is it a deep learning problem? Is it a process mining problem? At least at a high level, you want to understand how are these fields interacting with each other. And I gave you some references over here. For example, for me, going through this Udemy course on Dynamics 365 was pretty fabulous. I mean, like that was when I really understood all the mistakes I was doing for the last couple of years in the field as a data scientist, because I really didn't understand where does this plug in? Like when I do customer retention or propensity modeling, right? When I do promotion related problem, where does that plug into the system? When I do invoice processing, where does that plug into the system? And for me, this was a really fabulous course. It's a fairly short course. You can probably finish it in a couple of days, but it gives you a very vast exposure to what are the different components of an ERP system. And the beauty of this thing is that regardless of which company, I don't care which company you go work for, they will have an ERP system. They might not have Dynamics, they might have SAP, they might have ERP NetSuite, but any company has to have an ERP system, right? Beyond a mom and pop shop that are just using QuickBooks. And in that particular case, they at least have to have a finance and accounting system, right? But then as companies grow, they will have a formal ERP system. And the beauty of what's happening right now is that just about 3-4 years ago, a small company, when I say small company, like $5 to $10 million or $30 million, these kind of companies could not afford an ERP system. But with the cloud ERP system, even like a $3 million company is able to adopt an ERP system. And that's helping them digitize their processes and keep track of a lot of things, right? Because if you don't have things in a digital format, then you cannot really apply AI, right? Because you need data. Time series forecasting, I would highly recommend you learn some basic time series forecasting if you're in the realm of manufacturing, packaging, or logistics. Process mining is another really rapidly evolving field. Coursera has a fabulous course on it. It's actually being taught by the godfathers of process mining. Professor Van der Alf, he's from the University of Eindhoven. It's a fabulous course. Google or tools, definitely check this out. They have a lot of guides, so it'll actually walk you through different kinds of combinatorial problems like, job shop scheduling. There are many problems. There are like binning problems, routing problems, whatnot. So I think, it's a fabulous contribution by Google in the open source. It opened my eyes to a lot of very cool techniques that I didn't know how to solve before. And then obviously deep learning, everybody talks about it, so I don't have to mention anything about it. So that's the gist that I have right now. Let's open to any questions.
Thank you, Vish. That was a very informative discussion. And especially thanks for the references that you shared. I think personally, to me, those were very useful, and that's what I was about to ask you. And if there are any other questions, please, guys, feel free to type in.
So Anisha, where do I go? Can you read out the questions for me, Anisha?
Yeah, I'm just waiting on for questions. And okay, so there's a question for, will the slides be shared? So we will have the YouTube video on our channel. This will be uploaded over there. But for these slides, Vish, you might want to say.
Yeah, I'll share the Prezi link. So the Prezi, this is actually done in Prezi, so I will share the Prezi link that people can go and access.
Yeah, maybe you can just chat it or put it on the chat so that everybody gets it. Because yeah. Or maybe you can contact Vish.
Do you have an email list that goes out later where you share the link for the YouTube video?
Yeah, actually, we can do that. Yeah.
Yeah,
I think
let's
that's a
do
better
that.
idea. Yeah,
Yeah, I'll give you a link for the Prezi and then you can do that.
sure. And any other questions? And while you have questions, I'm just launching this small poll on how you like the presentation and this idea of webinars.
Mhm. All right, let's get a little bit of, these kind of webinars are always a little one-sided because when I'm talking, I'm not for sure who is on the other side. I find it a little challenging compared to a live audience.
No, that is true. But I think there might be typing and questions take some time, and let's just give people time to type in.
Was that clear? Are the different concepts and stuff like that? Or what did you?
Yeah, I mean, to me, it was a lot of new information, and I was just like wondering that, like you mentioned, time series. I have heard about it, but we are not taught that in the college level as such.
Mm-hmm.
And so, like the different topics that you shared, I mean, is there like a sequence in which we should be understanding them, or as a graduate student, if we are looking for um, like jobs to join in, and like what kind of skills are expected, and how do we go about it, because all of this is like really new information to me. So right
So
now,
the
if
way
I'm to, yeah.
so the way I think about it is don't go after the tools, right? Because otherwise you're gonna be too lost. Go after the problems. See, think about it, right? Here we took a use case, right? We have, say, you imagine that you're working for a company that is supplying food to Whole Foods and stuff like that, and then we work backwards, right? So
Hmm.
that's how I kind of what the narrative was in this particular conversation, right? We said, okay, we want to supply Whole Foods, Walmart, Chick-fil-A, all these companies, and okay, they're going to order, and I need to predict how many they're going to order because then I can plan, right? Because once they make the purchase order, I have very little time to fulfill that order. I better have all the ingredients with me at that time, right? So obviously you need time series forecasting. So obviously forecast is important, right? Then they're gonna send me all these invoices or all these orders online or email or faxes or something like that, and I need to convert that into digital, right? And that's where AI comes into play. And I want to make sure that I'm able to produce these things as fast as possible, right? So then you need combinatorial techniques, and you want to understand the bottlenecks in your process overall, right? So that's where process management comes into play. And you will learn these techniques, but keep an open mind. Like, when you go in, I see a lot of computer science graduates that go in, they can API the heck out of everything. I understand that you're really smart, but you really have to keep an open mind saying that, this is just not about deep learning and machine learning, or even what does that mean exactly? I mean, what are the different machine learning techniques? What are the different statistical techniques? How does this technique plug into this particular technique, right? Make sure that you keep an open mind. And I insist, I see this way too many times with computer science graduates. I almost have a negative bias in my mind against computer science graduates because they're a little overconfident about their skill. And when I ask very basic questions, it flips them over, right? And because you're a computer science graduate, you feel like you can just use an API and you feel very powerful. But I warn you, make sure you understand the different techniques that are available, right? Make sure that it doesn't turn into an overconfidence kind of thing, right?
Yeah. Thank you. And I do see some questions here. So Ellis is asking, what do you consider unique about the food packaging and logistics part for AI? This was very general about applying techniques.
For me, it's about purpose, right? Why, a lot of times, a lot of problems are really hard, in reality, right? And you need a purpose, you need a purpose so that when you get a difficult problem, you don't give up, right? So why do I like food packaging? It's not just food packaging. I mean, like, I just care about eating fresh food, right? And for me, everything, I mean, actually a majority of the work that we do in our company is marketing, right? We market fresh food. right? So we work with restaurant chains and so on and so forth to market fresh food, right? So for me, it's really about how can I use AI to solve a problem that gets the most fresh food on your table and the most tasty food on the table, right? If you look at the last 20 years, 30 years, I felt like food has been bastardized for the most part. Like, there would be these tomatoes that are plucked, that are completely green when they're plucked, and then they would just pump in nitrogen or whatever stuff in it. And they're just, shipped for like 2-3 months or whatnot. And I feel like, we can use AI to really optimize the supply chain so that we can eat fresh food. That's our, that's our right? So,
Yeah.
and that's a battle worth fighting. I mean, that's a problem worth solving, right?
Yeah, to add to that, even like we see a lot of food wastage, especially in like whole market world. So definitely, I mean, that hurts. Like, that hurts really bad.
Yeah. There's a statistic out there, right? I mean, 30. I come from India, and over there, 30% of the food gets wasted on the way to the customer. In developed countries, it's typically 30% of the food gets wasted in the refrigerator, right? So, we got to be aware of this. And where I'm getting to is, see, I almost stopped buying food from Costco because, you're hoarding a lot of food and you're not eating fresh food. You're wasting a lot of food. For me, it's really about getting the right quantity of the food to the house, just eating it that day and just buying fresh food the next day, But if you try to do that today in Whole Foods, it costs an arm and a leg, right? It's really expensive to buy small quantities of really fresh food nowadays, right? So this is not a solved problem. It's far from it, right? And it's a problem worth solving, right? When I came to the US, it was hard buying any fresh food at all. Like, the idea of fast casual, like Fuzzy's Tacos or any of the fresh food wasn't there. You go to a Wendy's and you eat like all this processed food, under $5, under $6, you barely had any choices for healthy food. It was really, really difficult, right? And then there was a whole movement that came out. I don't know if you guys saw Super Size Me. Like, it came out about 2008, 2009. That's when the movement towards fresh food started. So you'll see a lot of fast casual restaurants that popped up. Chipotle was one of the earlier ones. But you see Chipotle, you see Fuzzy's Tacos, you see Velvet Taco, you see Smash Burger, Mod Market. These are all the fast casuals that came out because there's so much demand, because people started demanding good food, fresh food. Yeah.
And so Dalia has a comment that I actually expected to see AI in more operational processes like manufacturing, packaging, sorting.
So that's where, when you look in, typically if you look at, what I learned, right, when I'm working with manufacturing and packaging companies, is that they started employing a lot of industrial engineers, right? And industrial engineers know a lot of these processes. They understand process, right? If you think about Lean Six Sigma, workflow diagrams, that's in the realm of industrial engineers. And I learned a lot of very, very cool techniques from them. So these combinatorial techniques, they're also called linear programming techniques. These are all coming from that operations background, folks, right? But the thing is, they don't appear in isolation, right? You still need time series techniques, which are statistical techniques. You still need AI, right? So what is the biggest opportunity for our generation is to put these techniques together, right? It was nearly impossible. I mean, like, you have to be like a $6 billion, $10 billion company before to hire these really expensive operations research people and these deep learning people to solve even, fairly simplistic problem nowadays, right? Because now you have Python libraries that Google just open sourced and Microsoft just open sourced, or they're available as a cloud service. So, but the thing is, you need to be aware of these techniques, and then you'll know, should I go to a Microsoft cloud or should I go to an AWS cloud? Because you know what? Sometimes this service is available in IBM, that service is available in the AWS, this service is available in Azure, and maybe there's a technique that is just in the open source and nobody has yet productized it, right? So you want to be aware of all these techniques.
Then Steve is asking that as consultants, we go in and troubleshoot and fix an issue. After the project is over, what is the company's preferred way to take over and own the problem? What would they prefer the consultant to provide?
That's a very challenging question. Good question, actually. You see, what I've noticed as a consultant is there are companies that are ready for AI and there are companies that are not, right? Because traditionally, if you think about a lot of companies, it was a very requirements-driven process, right? Somebody needed a ERP system, so they would spec it out. It would go into production, and they would be like, okay, at that point of time, it is just maintenance. The problem with AI and machine learning is that you're never done, right? I mean, it takes a lot of time to basically, you need to iterate very fast, right? Because it's usually in the 5th or 6th iteration that you kind of like optimize the problem well enough that you're like, okay, the incremental money that we're going to make, is going to be very less. But it takes a lot of experimentation to get there, right? And the companies need to be built for that. And a lot of leadership is really not thinking in this direction, right? I mean, you have very few companies like the Ubers of the world, the Googles of the world, the Microsofts of the world, the Capital Ones of the world. But a lot of companies, the leadership, they haven't really relearned what is now possible with the cloud services with AI, right? And we as consultants, our job is to keep educating them, right? And make sure that we set expectations that, hey, this is a machine learning project. Don't expect that the first deployment is going to work. Manage their expectations so that you're constantly educating them as consultants, right? You want to make sure that you're defining the problem. You're basically setting expectation during the POC phase that, hey, we're expecting maybe a 40% increase in redemption rate or, better prediction rates for our time series or something like that. But you want to set expectations, and then you want to make sure that there's a culture of experimentation. It's a very hard problem. It needs to come from the very senior leadership. And it takes a certain amount of education on the customer's side as well. Does that answer your question?
That answered your question, Steve. Yeah. So Wang is asking, where is your company? Oh, I know it's in Dallas. It's in Texas. Right?
Yeah. So we are based in Dallas.
And do you deal with manufacturer vertical?
We deal with packaging vertical. Slowly, hopefully into manufacturing, but yeah, food packaging, I guess that's where our that's one of our clients are.
And one more question, it's kind of unrelated, but yeah, how about AI in education sector? And then what companies in India are into AI based restaurant management, if you know?
Second question, I have no idea. But AI in education, I think education has to be rethought quite a bit, right? I mean, so Divergence Academy is our parent company, and that's where I got trained as a data scientist. I actually, I wanted to join a formal data science master's program back in 2014, 2015, but I chose against it because I did not feel like spending 2 years without getting any feedback, right? It's a lot of times you overthink a lot of things, right? Like, initially, I was thinking that, oh, I have all this AI knowledge. I'm going to go to a supplier of Walmart and solve AI. And you go to almost a $600 to $800 million company that is supplying nearly $1 billion worth of fresh cut fruit to Walmart. They don't even have an ERP system. They're taking all the orders on an Access database, and that's what gets you, right? Because you got to understand where they are at. And if they don't have an ERP system, AI has no business there, right? You first have to have at least a basic ERP system in place. So, having that perspective, but the thing is, if you wait for 2 years, like, you still haven't gone to any of the manufacturing facilities, right? If you're in school. And a lot of times it's a lot of feedback, right? Your brain doesn't learn linearly, right? You want to learn a little bit of this, a little bit of that, and then you reinforce that a lot, right? But in formal school, you're taught the same darn thing for like 6 months, right? And I just don't like that. So that's the reason why I like our academy, because it's very iterative, it's very fast. You take realistic examples, you learn enough basics, but then you start tinkering with it. You get more reinforcement of your learning. Then you go back, you learn a little bit of deep learning, you learn a little bit of this process mining, you come back. You're always, but the thing is, the center of it, you're trying to solve a very clear problem, right? So at least that keeps your motivation alive. So AI in education, you know, that's a little, I mean, obviously on a platform, you want to be, you know, I am always very curious, like, you know, how many people take Coursera courses actually finish them, right? How many people who start taking Udemy courses actually finish them and actually understand what's going on? The problem that I see with these online courses is that they're great, right? They're great once you have an idea, but the thing is, they create this false illusion that you don't need a good mentor. I feel like you need a good mentor now than any time in history, because you're overwhelmed with information, right? You know, right now I just threw about 6 different fields on you, right? But in what order do you solve these problems, right? You know, that process mining course alone, you could do it for another 3 months, but is that the right thing to do, right? So one thing I would strongly urge is that have a good mentor, because you could easily get lost in this ocean, right? I could not have been here without my mentor. I'll tell you that. I mean, I literally wasted about a year and a half, not wasted, but I was literally doing all these University of British Columbia courses, MIT courseware, all these courses for almost a year and a half. I still don't know how to solve a real problem, right? And that's a problem that people are running into nowadays, is that there's just too much information. So and education is not cheap, guys. Like, you know, that Udemy course might cost you $20, but it doesn't give you perspective. A mentor can give you a perspective, right? So, and I wouldn't basically discount the price. You know, there's a price to be paid for an education, right? So make sure that you value that, and don't assume that everything is just $30 or $40, right? So, you know, but the thing is, choose your mentor carefully.
Thank you, Vish. I think you just hit the bullseye with that comment on mentors, and that we are overwhelmed with information. I feel that at times. I feel most of the times like that. I hope it solved we have answered all of the questions. I don't think we've missed anything. If there are no more questions, and if you want to personally reach out to Vish, please feel free to do that. And we have his contact information, and we'll just share it with all. And I think there are no more questions. Okay. Thank you, Vish, for your time today. And have a great rest of the weekend, everyone.
Thank you all. Pleasure being here.
Thank you. Bye.